Application of partial derivatives. Covering Euler's theorem, total differentials, maxima and minima of functions of two variables. Now question is given, let ux comma y equal to x power cube plus y power cube minus 3axy, where a is a constant. Point A. Verify Euler's theorem for the functions ux comma y. Second point B. Find the total differential du of the functions. C point. Find the stationary points and determine their nature, maxima, minima, or saddle points. This is important for these questions. Now we are going to solution. A point, Euler theorem. Euler theorem for a homogeneous functions of degree n in two variables states x partial u upon partial x plus y partial u upon partial y equal to nu. First check whether ux comma y equal to x cube plus y cube minus 3axy is homogeneous and determine its degree. Now each term is of degree 3. You can see here x power cube. First you write here x power cube, degree is 3. And second is y power cube, degree is 3. 3axy. Degree from a is 1 plus degree from x. X degree is 1 plus degree 1 from y. You can see here 1 plus 1 plus 1 equal to 3. So, U is homogeneous of degree 3. Now, you can see here we are going on a next step, compute partial derivative. First, we get the derivative partial u upon partial x. It means the derivative of function u with respect to x. Then we get 3x square minus 3ay. Now function u derivative with respect to y, we get 3y square minus 3ax. Apply Euler theorem. X, this bracket you can see here, partial u upon partial x, we write the bracket values and plus sign, then partial u upon partial y, the value we get, then we put here. Now we multiply this bracket, x multiplied by x square, we get 3x square. Now you can see here minus sign, you can see minus sign we write here, and x multiplied by 3ay, we get 3axy. Plus sign, you can see the plus sign is given, we put in the values of plus sign. Y power 1 and y power square multiplied by y power 3 plus multiply by minus, we get minus y multiply by 3ax minus का 3axy. Now you can see we simplify these values, then we get, because we have getting the values of common 3. You can see here minus 3axy and minus 3axy, then you can write here minus 6axy, then 3 we get the common values in all three terms. The original u equal to x cube plus y cube minus 3axy. So x partial u upon partial x plus y partial u upon partial y equal to 3u plus 3axy. Therefore, Euler's theorems does not hold exactly unless a equal to 0. That is because u involve a non-homogeneous constant a, which disqualifies it from pure homogeneity. Pure homogeneity. Euler's theorem is not satisfied unless a equal to 0. This is a condition for Euler's theorem. Now you can see here we find b point total differential du. Must be remember this formula du equal to partial u upon partial x dx plus partial u upon partial y dy. You have already get the values of partial u upon partial x, then we put in these values. Dx you write same, plus sign here is given, you write same. Partial u upon partial x you have already write, then put in the values of here. Now dy we write here. Final expressions du equal to 3x square minus 3ay dx plus 3y square minus 3ax dy. We get the answer total differential du. C point maxima and minima stationary points. To find a stationary point set partial u upon partial x equal to 0 comma partial u upon partial y equal to 0. You must be remember. You have already get partial u upon partial x, then we put in these values equal to sign we write here 0, then you write here. Now we simplify these terms. You can see here 3 in given both terms, then all the values we divide by 3, we get x square equal to ax. Again, partial u upon partial y, we put in the values of partial u upon partial x, then equal to 0. 3 are given in both terms, then divide by 3, then we get y square equal to ax. You can assume this is the equation number 1 and this is the equation number 2. Substitute 1 into 2. It means 1. This statement, this terms will be put in terms 2. Now y square equal to ax. You can see here we put in the values equal to a is given the value of x square upon a equal to x square implies y square equal to x square implies that y equal to plus minus x. This is very simple functions. You can see here this is very important. Substitute 1 into 2. This is x square ax. Put in the values of in this form because we want to find the value of y. Now we put in the values of in these terms, then we simplify. After these terms we can get, because is the x y squaring on both sides, then we get plus minus sign x. Now you see here from equation 1 x square equal to a y. If y equal to x, now x square equal to a and y equal to x, then we simplify. Minus ax convert here side, then minus ax equal to 0. Then we get the value of x is common in both value. After the getting the value x equal to 0 we get, and the value of x equal to a we get in these terms. Then x equal to 0 implies that y equal to 0. X equal to a implies that y equal to a. If y equal to minus x, x square equal to a minus x. Now we simplify these values, these terms, then we get the values x equal to 0 and x equal to minus a. Same process we have find in this step, then we simplify. Now x equal to 0 implies that y equal to 0. X equal to minus a implies that y equal to a. Stationary point 0 comma 0 a comma a minus a comma a. Classify, compute the second partial derivative. Ux equal to 6x, uyy equal to 6y, uxy equal to minus 3a. You already know what is uxx, 2 times derivative with respect to x. What is this? Partial u upon partial y, then again partial u upon partial y. Same process, first partial u upon partial x and second time partial u upon partial y. Use the second derivative test. Let d equal to uxx multiply uyy minus uxy power 2. Evaluate at each point. At 0 comma 0, uxx equal to 0, uyy equal to 0, uxy equal to minus 3a. D equal to 0 multiply by 0 minus 3a power 2. Now we simplify, then we get minus 9a power 2 a square less than 0. Saddle point at a comma a uxx equal to 6a uyy equal to 6a uxy equal to minus 3a. Equal to 6a multiplied by 6a minus, now we put in the values of uxy whole square. After this simplification, 6 multiplied by 6, 36a square, because a is given. Now square, it is a 9 and minus sign is given, 9a square. It means now we simplify, then get 27a square. After the simplification, because a square and a square both are given, 36 minus 9 we get 27a square greater than 0. Since uxx equal to 6a greater than 0, local minimum at a comma a. At minus a comma a, uxx means second derivative with respect to x minus 6a. Yy means 2 times derivative with respect to y we get, and uxy means first time derivative with respect to x and second time derivative with respect to y equal to minus 3a. D equal to, after the 14 values, this we can see here, then we simplify 6 a square minus 9a square. After the simplification we get minus 45a square less than 0. Saddle point. Final answer. Euler theorem is not satisfied unless a equal to 0. B. Total differential. You can see we have right here the answer. C. Stationary point and nature. Stationary point 0 0 saddle point. A local minimum minus a comma a saddle point. Okay, take care.